Voyagers have discovered something horrible that has never been seen before. Being the only artificial objects to travel farthest from the Earth, the Voyager Space Probes have been operating in space since their launch in the 1970s. They have spent almost 45 years in space instead of the planned 5 years. NASA's Voyager 1 spacecraft continues its sail into the interstellar, sending strange signals to Earth. Scientists still hold on to the belief that we will be able to maintain contact with the spacecraft until 2025. But will they be able to reveal anything else? Will their journey continue? There is a high probability that it may stop functioning soon. But what will happen then? Stay until the end to find out. Welcome to our channel, where we provide you with facts related to space. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so you may never miss any of our updates. The Voyagers were initially launched to reach Jupiter and Saturn and explore the major moons of both planets. Thanks to the Voyagers' images, scientists could see the moon's surface around Saturn, which previously seemed to be just bright dots. That was the genesis of explorations related to one of the moons, Enceladus. Scientists were shocked by the fact that Saturn's moons showed geological activity. A moon is usually covered with craters that didn't change despite any collision resulting in scars. Full moons are stationary, and there is no geological activity in them. However, Enceladus is different, as it appeared so smooth, which could mean it is forming an atmosphere, and one day life could originate from it. Later we know that the reason for Enceladus's smoothness is cryovolcanism. Cryovolcanism means the extrusion of liquids and vapor of materials that would be frozen solid at the temperature of the planetary surface of the icy bodies of the outer solar system. In the early 70s, before they left for the Voyagers, nobody knew of this, as well as of Jupiter's moon, Io, which seems like a tiny ball of rock and ice at a distance of 800 million kilometers from the Sun. However, the legendary space probes presented the scientists with a new picture of everything. There was no ice, only raging volcanoes everywhere. The eruption of the largest of the volcanoes reached a height of 400 kilometers. That was the first time active volcanoes had been seen somewhere other than our Earth. It turns out that Jupiter's enormous gravity makes the moon's tectonic structure constantly moving. This results in extreme volcanic activities. Going far beyond Io's surface, the space probes also showed scientists Jupiter's radiation belts in the never-before-seen planetary rings. These planetary rings were first discovered by Voyager 1 in 1979. Voyager 2 later came to it and conducted more extensive exploration, which allowed a rough determination of the ring's structure. Then it was Saturn's turn, the owner of the most extensive ring in the solar system. NASA's Cassini spacecraft spent 13 years in the solar system exploring the moon. It gave information about Saturn, which consists of countless small particles ranging in size from micrometers to meters. However, if the Voyagers hadn't captured weird interlacing around Saturn, scientists would never have sent Cassini to the same route. The same happened with Saturn's moon Titan. The Voyagers were the first to discover liquid seas on Titan. Cassini only went there to confirm it about 40 years after the first discovery. The Voyager's mission was stipulated to end after 5 years of exploring the two planets. But luckily, the task was extended to Uranus and Neptune. Voyager 1 headed into the unknown moons of Jupiter. But didn't it cross your mind that a 5-year mission was extended without returning to Earth to take off again? How did it happen? It isn't magic, just the work of technology. The twin Voyager probes weigh 773 kilograms each, while newer machines, such as the Japanese Akatsuki, released in 2010, are at least 200 kilograms lighter than the Voyagers. Of that total weight of 773 kilograms, Each Voyager carries 105 kilograms of scientific instruments. These include the Imaging Science Subsystem, or ISS for short. The ISS consists of 2 television cameras. The first is the wide angle with a low resolution of 200 millimeters. In contrast, the second one uses a narrow angle lens with a higher resolution of 1500 millimeters. Still, these technologies are minions compared to what the James Webb Telescope entails, with several sophisticated lenses and prisms, numerous shutters, and autonomous modes. Nevertheless, the Voyagers stirred. Even when the mission moved farther from the Sun, the objects and the photos became dimmer. The Voyagers managed to transmit thousands of images with a storage capacity of only 67 megabytes. One of the features that made the Voyagers unique isn't about the camera, but its power. Each Voyager has 3 radioisotope thermoelectric generators, and the fuel used is plutonium-238, which turns heat from the decay of radioactive material into electricity to power the spacecraft. The probe's ability decreased in 2011 by 57% compared to its launch power. So more than the remaining capacity would be required to keep all the subsystems running for so long. This made the scientists shut down some of them to save energy. But how didn't it affect the Voyagers as they continue their exploration billions of miles from Earth? Can you answer the question? We'll answer it for you. It's all about a carefully chosen launch time. Scientists took advantage of a rare alignment of the outer planets in the late 70s. This arrangement of Jupiter, Saturn, Uranus, and Neptune occurs approximately every 175 years. This allows a spacecraft to follow a particular trajectory and make a 4-planet tour for a minimum trip time. This is the so-called gravity assist. When passing each planet, the space probe uses its gravity to increase its speed and reach its destination. Using this technique, the flight time to Neptune was reduced from 30 years to 12. Voyager 2 was first launched, and its trajectory was developed to fly past Jupiter, Saturn, Uranus, and Neptune. Voyager 1 was launched second, but on a faster and shorter course. It was designed to send the spacecraft's costly parts. Voyager mission devices help scientists get information about the interstellar medium parameters, which can't be obtained in any other way. Researchers hope to gain enough info while the Voyagers still have fuel. However, there is a but. Voyager 1 seems to need to be recovered. In 2022, NASA announced that the readouts from Voyager 1's attitude control system didn't match the spacecraft's movement. Scientists assumed the probe was confused about its location in space, which is how it works. The attitude control system sends data about the interstellar medium surrounding the spaceship. The signal passes through a giant antenna directed toward our planet. Still, now it only gives engineers random numbers that don't reflect what's happening on board, and scientists need help understanding the nature of the problem. If they do it, we may retain Voyager sooner than expected. The scientists' task is complicated because the probe is very far away. Voyager 1 signals take 20.5 hours to reach Earth and exchange messages with the space agency, and the investigation takes 2 days. There's another problem. Back in the day, thousands of employees worked on the Voyager mission, but today no more than 20 people are working part-time. That's too bad, because there's still something the Voyagers could see when the probes run out of power. They can still get stuck in zero gravity. The Voyagers use fuel to keep the subsystems running, so they'll continue to fly. But they'll stop turning the antennas in the right direction and sending signals to Earth. Currently, the Voyagers have moved beyond the influence points of the solar wind. After 20,000 years, they'll cross the Oort cloud, a swarm of comets and icy debris orbiting the Sun at a distance of up to 100,000 astronomical units, 100,000 times the distance from the sender to the Earth. It will be the final destination of the journey through the solar system, And although we'll lose contact with the probes by then, they'll still be silent witnesses of space phenomena. After 500 million years, the Voyagers and the entire solar system will make a full revolution around the center of the Milky Way. You guys know everything in the galaxy revolves around the center. Right now, it's impossible to predict what will happen on Earth by then, but in the past, in that amount of time, the supercontinent Pangaea formed and collapsed. Scientists also assumed that in galactic orbit, the spacecraft would oscillate up and down at the same time. Voyager 1 will oscillate more dramatically than his twin. According to assumptions, Voyager 1 will travel so far above the main disk of the galaxy that it will see stars at just half the density as we do from Earth. Besides, the same difference in vertical motion will also shape the differing odds each spacecraft has of survival. Yes, you heard me right. Survival is the thing. The Milky Way's vast clouds of interstellar dust are very dangerous, because the dust will pound into the Voyagers at speeds of a few kilometers per second. And then even a dust gram only 1,000th of a millimeter across will leave a small crater. These grains will steadily hit the hull, which can slowly chip away at the spacecraft's skin. Of course, the dust won't change the trajectory, but the gravity of the Milky Way's clouds can easily do it. The clouds have so much mass concentrated in one place that they may fling the spacecraft into new orbits, sometimes much farther out, even deeper towards the galactic core. In this sense, Voyager 1 is at a greater risk because its vertical oscillations mean the spacecraft will spend more time above and below the galactic plane where the clouds are thickest. But despite the potential dangers, the Voyagers will probably have time to visit another star. Voyager 1 will move to the constellation Ophiuchus, and millions of years later the probe will say hi to a red dwarf named Gliese of 445 in the constellation Camelopardalis. Meanwhile, Voyager 2 will reach the constellations Sagittarius and visit a star named Ross 248. It could also be that the Voyagers will see stars that haven't been born yet. But why should we care whether the Voyagers will meet them if we no longer exist by that time? We actually should, because the probes carry valuable cargo, destined for distant civilizations. 2 golden records with a collection of information about humanity and our home planet. They contain photos of the Earth, sounds of animals and birds, and words in various languages. It also contains communication of our solar system, about pulsar stars, and even instructions on how the record is to be played. This seemingly frivolous idea may well be the last proof of our existence, because the records were designed to last billions of years in space. Under the gold plating, there's a protective aluminum cover, and beneath it, there are engraved copper discs. The Voyager Space Probes were sent into space 45 years ago, exploring and sending information on its discoveries. The Voyager's planned mission was 5 years, which they have exceeded by quite some time. So it may stop any time now. What is your opinion on its stoppage? Would the cameras still be working? How will information be disseminated in this state? Can NASA send another Voyager to the interstellar region? Thanks for watching this video. Do tell us your views in the comments box. For more educational videos like this, subscribe to our channel and hit the bell icon so you won't miss any future updates. See you in the next video. Bye.